So the first question says the motion of a door when a force is applied on its handle. So what kind of motion is this? So this will be a rotational motion. We can also say angular motion, but in your textbook they have given the answer as rotational motion. Because see, if we are seeing the door from the top and here it is pivoted or hinges are here, and if we are applying forces like this, so we can say it will rotate, our door will go like this. But if we see, there is some angle also getting here. We are getting some angle here. So that is why we can also say it is angular motion. But for a textbook, we will go for the option A as a rotational motion. Now, for the second question, the moment of force about a given axis depends on the moment of force, the torque, depends on what? That is what we need to think. Only on the magnitude of force, only on the perpendicular distance of the force from the axis, neither the force nor the perpendicular distance of the force, or both the force and its perpendicular distance from the axis. So the last option will be the correct. You can see it from this formula. So this is the formula for moment of force, calculating it. So what will depend on? It will depend on the force, the first thing, and it will depend on the perpendicular distance. So both things will matter if we have to think about the torque or moment of force. So it will depend on two things. Let's read this question. For producing the maximum turning effect on a body by a given force, the perpendicular distance of the line of action of force from the axis of rotation should be, it should be as far as we can go. For example, if let me draw again, let's say I have a rod, I have pivoted from here. So if I want to create the maximum turning effect, I have to apply force here, right? Because if I will not apply force here, and instead of this, I'll apply force this side. Now the turning effect will be less. Remember, the force in both the cases is same. So I'm applying same force, but the turning effect by this force will be less. Why? Because the distance also matters in rotational effect or moment of force. So distance will be less, our torque will be less, or our moment of force will be less. But in the second case, the distance is more. That's why we keep, if you see our doors, we keep the handles as far as we can to get the maximum rotational effect. So the answer will be C here. The moment of force for anti-clockwise movement is taken as positive, and for clockwise movement is taken as a negative. So this is just a convention. We take it like that. You can take otherwise also, but generally we take the positive angle as anti-clockwise, and it is coming from the angle. So like in geometry, if we want to take an angle, we take anti-clockwise and we say this is 30 degree. We say it is a positive 30 degree, right? So we are taking which direction? This is the anti-clockwise direction. So similar convention we use when we are talking about the movements of force. So if it is the turning effect is towards the anti-clockwise direction, we will say it is a positive one. If it goes clockwise, then we will say it is negative. So that is just a convention. So the answer will be A. Let's see this question. The direction of rotation of a pivoted body can be changed by changing what? So if we want to change a pivoted body, what we can do about it? So for example, attending these kind of questions, we can draw a figure. So I've drawn a small seesaw. Let me draw it here for you. Let's say pivoted body, a bar, and this is the pivot. So this is my pivot. Now I can do two things. First thing, if I push it like this, my rod will go like this. So it'll be a anti-clockwise movement. So I can change the direction of rotation like this, or I can do apply force like this. So if I change the direction, now I will get to the clockwise rotation. So changing the direction of force, of course, we can change the direction of rotation. Also, I can do one thing. In this example, the seesaw example, if I apply a force like this, the rotation will happen this way or anti-clockwise. What if I change the point of application of force? Instead of this, I put it the force here, right? So I'm changing the direction of force. No, the direction is same upwards, but now I'm changing the point of application of the force. So if the this pivoted body is now applied force here on this point, it will go in another direction or clockwise rotation we will get. So I can do both the direction of force and the point of application of force can be used to change the direction of rotation. This is MCQ number 6. A couple is formed when dash are not acting along the same line. So The answer is it's just a definition of a couple to equal and opposite parallel force, right? They are not acting along the same line. For example, if this is my disk and this is one force and equal and opposite force, parallel force, right? If I apply, then I'll get a rotation. So we will say the couple is acting on this body. So we say that the forces should be equal, they should be parallel, and they should be opposite to each other. And if they are not acting on the same line, see the line of this force is this, and line of this force is this. They are not in the same line. Right? That's why we are getting the couple. Let's go next. As per the principles of movements in equilibrium, sum of anticlockwise movement is greater than sum of clockwise movements. Sum of anticlockwise movement is equal to the sum of clockwise movements. So this is what the actually the definition of principle of movements. That's how we apply. Like for example, let me give you example. Like let's say this is a rod and it is pivoted from here. Right? So if I put a 1 kg mass here, 1 kg, so the force will be 1 kgf downwards. So it will rotate, right? But the principle of movements in equilibrium, this is not in equilibrium as of now, because this will rotate like this. It will go like in the clockwise direction. It will rotate. So what if we want to keep it in rotational equilibrium? I'll put another mass here at the same distance. So this distance and this distance is same. And if I put 1 kg here, 1 kgf, now obviously it will balance. It is in equilibrium. And now we can say why it is in equilibrium, because this mass is creating clockwise movement and this mass is creating anti-clockwise moment, and their movements are equal. If they are not, it will not be in equilibrium. For example, if I'll not apply this here, let's see, if I take this and apply it here, now what do you think? It'll be in equilibrium? No, this will go down. This moment will be more, right? Because now we have increased the distance from perpendicular distance from the pivot, so it will have more movement in the this side, anti-clockwise side, and the clockwise movement will be less, so it will rotate net. There will be a net movement in this. So when in case of equilibrium, as we were doing this case, in this case the movements will be equal. The clockwise movement and the anti-clockwise movement has to be equal. That's why it will be in equilibrium, otherwise it will not be in equilibrium. Now let's see the eighth question. The body is acted upon two unequal forces in opposite direction, but not along the same line. Remember, they are saying two unequal forces, they are not equal. The fact is that the body will have both rotational as well as translational motion. Both things will happen, and we can try by the pen fight game also. Like for example, if there's a pen lying here and your friend applies some force here and you apply force here, so it will rotate. If these forces are equal, double dash, I'm drawing the double dash, it means that the forces are equal. So now what will happen is these forces are equal, so it will only rotate, or we will get pure rotational motion. Pure rotational motion we'll get. But now what if in this case, let me provide a different forces. So this much your friend has applied and you're applying more force this side. So here are the unequal forces in opposite direction, right? So this body is getting acted upon unequal forces in opposite direction. Now what will happen? See, one part of it, you can think of it like this. One part of this force will rotate it, right? And the rest of that, let's say this much, right? This much part of it, this much, which is equal to this, will try to rotate it, right? It will rotate like this. And what about the rest of, because you are applying more force, it's not equal forces. So this part will give it the motion of translation. It will move. So we will get two things. We will get rotational motion also, as we will get the translational motion, because the forces are unequal. Let's do question number 9. Here we are saying that body will be in equilibrium. Equilibrium means it should not change its state. So which of the conditions is necessary? First thing is movement should be zero. If movement will not be zero, it will rotate, right? So it will not be in equilibrium for that. So this condition has to be met. And the last condition is the acceleration should also be zero. In your textbook, I think only this is marked as answer, but this is also should be the answer, because if acceleration is there, then of course force is there. And if we are accelerating something, it is not in the same state of motion, so it will not be in equilibrium.